So today we have an interesting geometrical problem. The diagram is on the screen with all the given details. Now the question over here is to find the value of area of the blue region upon area of the pink region. So this is Anmol and now let us see the solution. How can we solve this problem? So first of all I will start the solution by taking the radius of this semicircle as a variable. But before that let us mark the center of this semicircle as the point P. Now let us take the radius of this semicircle as a variable x. Therefore, the diameter of this semicircle becomes 2 times x, and that is ultimately the side length of this square. Hence we have got the length of side of the square, and that is going to be 2 times x. Now we can clearly see that in order to get the value of the required fraction, we need to get the area of the blue region and area of the pink region. Now we can see that this pink shaded region is not a perfect shape, but still we can get the area of this region by subtraction of areas. So there will be an equation form in order to get the area of the pink region. So we can obtain the pink region by taking the area of this complete quarter circle. So area of the complete quarter circle, so area of the quarter circle. Now subtracting the area of this semicircle from that quarter circle. So minus the area of the semicircle. Now we need to subtract the area of this blue circle also. So you can see that from that complete quarter circle, I removed these yellow regions, and what is remaining is the pink region. So area of the quarter circle minus area of the semicircle minus area of the circle gives me the pink area. Now we have got the side length of the square, that is 2 times x, and that is ultimately going to be the radius of the quarter circle. Now area of the quarter circle is pi, the radius square, so 2 times x the complete square divided by 4. Minus area of the semicircle. Now radius of the semicircle we have taken as x, therefore area of the semicircle is pi radius square divided by 2 minus area of the blue circle. So I will just write it as the blue area. Okay. Now over here we can see that this term will turn out to be pi x square and this term will turn out to be negative pi x square upon 2. These are like terms, so we can simplify this thing. So this will give me pi times x square upon 2 minus blue area is ultimately the pink area. Now this is an important equation because it is giving us the area of the pink region. Now we will try to find the area of the blue region. Now we can see that the blue shaded region is the area of this particular circle, and this circle is not a random circle. The position of this circle is perfectly defined by the tangent point. It is tangent to the semicircle, tangent to the quarter circle, tangent to the base of the square. So I will simply utilize this fact in order to find the area of the blue region. Now in order to get the area of this blue region in terms of x as we did in this pink area, I need to get a relation between the radius of this blue circle and the variable x. So first of all I will take the radius of this blue circle as a variable y. So now the goal over here is to find a relation between y and x in order to get the area of the blue region in terms of x. Okay. Now it was given that the circle is tangent at this particular point. I have already drawn the radius, hence the angle over there would be 90 degrees. Now we can see that the circle is also tangent to this quarter circle. So recall the theorem that if there are two circles that are tangent to each other either externally or either internally, in both the cases, the tangent point, the center of the two circles are going to be collinear. So the same thing can be utilized over here. The circle is tangent to this semicircle externally, and the same circle is tangent to this quarter circle internally. So when I will draw a line segment, first of all let us talk about the quarter circle. So for the quarter circle, this is the center, this is the center of the circle, and here is the tangent point. Hence we can simply draw a straight line that will join these 3 points. Similarly, this is the center of the semicircle, here is the tangent point, here is the center of the circle. And again we can simply draw a line segment joining these 3 points. Now what about the length of this line segment? So we can see that the distance from here to here is the radius of this quarter circle, that is going to have a value 2 times x. The distance from here to here is the radius of this blue circle, that is going to have a value y. Therefore this remaining distance is going to be 2 times x minus y, and the complete distance is going to be 2 times x plus y. So this distance is 2 times x minus y, and the longer distance we don't need. Okay. Now what about the length of this line segment? So the distance from here to the tangent point is the radius of this semicircle, hence it would have a value x. The distance from the tangent point to here is the radius of the blue circle, hence it would have a value y. Therefore the complete distance from the point P to the center of this blue circle is going to be x plus y. Now we can even see that this angle is 90 degree because it is the corner of this square. Okay. Now here we have a right angle triangle. The length of the hypotenuse is 2 times x minus y. The length of the height is y. Therefore by applying the Pythagoras theorem, the length of the base is going to be square root of 2 times x minus y, the complete square, minus y square. This is the length from here to here. So here we have utilized the two things. First thing is that the circle is tangent to the quarter circle. From that only we got the length of the hypotenuse. And the second thing that the circle is tangent to the base of this square. From there we got this height. Okay. Now what is remaining is this particular fact that the circle is tangent to the semicircle. So in order to utilize this particular fact, I will draw a line segment from the center of the blue circle that is parallel to the base of the square and meet this side of the square. Okay. Now as this line is parallel to the base of the square, these two angles are going to be 90 degree by collinear property. Now this angle is 90 degree by linear pair. Okay. Now we can see that this particular quadrilateral is a rectangle because all the four angles are 90 degree. The breadth of this rectangle is equals to y. Therefore, the distance from here to here is going to have a value y. The distance from the point P to the base is equals to x. Therefore, the remaining distance over here is going to be x minus y. Okay. Now again, this was a rectangle. The length of this rectangle we have already got, that is square root of this thing. Therefore, this yellow line would also have the same length. Okay. Now in this right angle triangle, we have the value of the hypotenuse x plus y. We have the value of the height, that is x minus y. We have the value of the base, that is square root of this thing. Hence we can apply the Pythagoras theorem. So as per the definition, the hypotenuse square, so x plus y the complete square, equals to height square plus the base square. Height is x minus y, so x minus y the complete square plus the base square. The value of the base is square root of 2 times x minus y the complete square minus y square all in square root. Now this term the complete square. Therefore the value of y is going to be x upon 2. So here we have got the value of y in terms of x, that is the radius of the blue circle in terms of x. Okay. Now let us write down the area of the blue region. So the blue area is going to be, as it is a circle, pi times the radius square. Radius we have taken as a variable y. Now we have got the value of y in terms of x, that is x upon 2. So pi times x upon 2 the complete square. So this thing is going to be pi x square upon 4. And this is the blue area, and that is completely in terms of x. Okay. Now recall that we have got the area of the pink region, but in that we need to subtract the area of the blue region. Now we have got the value of the blue region, so let us replace the blue region in that equation with this value, that is pi x square upon 4. Now pi x square upon 2 minus pi times x square upon 4 will simply give me pi times x square upon 4. Now I will simply divide these two equations. Therefore, blue area upon the pink area is going to be pi x square upon 4 divided by pi x square upon 4. Now we can see that the numerator and the denominator are exactly same to same. So the fraction of this thing will simply give me 1, and that's the answer that we were looking for. So this was my way to solve this particular problem. If you have any other method other than this, or else if you have any other question that you think I should try, you can do comment below, and if it's hard to comment, you can email me, or else you can send it to me on my Instagram. The link is in the description.